Hello guys, welcome back to a new video. In today's video we're going to start with a new chapter, that is linear equation in two variables, class 10th. So let's begin. So before just starting this chapter, let's talk about some basic concepts that you guys need to know. First, the difference between expression and equation. So an expression is, for example, x square plus 2, 2x plus 3y, comma x cube plus 3x square. So expression is these. For you can take them as a reference to identify other expressions as well. And what is an equation? Well, simply an equation should contain equal to sign, is equal to sign, sorry, equal sign, equal to sign is compulsory. So whatever polynomial contains equal to sign, it can be termed as an equation, not as an expression. So that's the basic concept that you guys need to know right now. And now, linear equation in one variable. What is linear equation in one variable? Linear equation in one variable. One variable. As the chapter's name suggests, that it is two variable. But some students might confuse it with one variable, or while they're solving questions, they might take the wrong option by saying that okay, there's a variable, that's the correct option. No. Linear equation one variable means x is equal to 3 as an example, x is equal to 3. Now here we know the degree. What is the degree? 1. The highest possible power of a variable is 1. That's why it can be termed as linear equation in one variable. As you can see, there's only x. You can also write this equation as like this also, x minus 3 equal to 0. Right, this is much simpler. So here we have power 1 and this is coefficient, sorry, a 0 term. So it will have power 0, so it doesn't matter. Okay. So that is linear equation in one variable. Now if we see, now if we just one second. Now let's see linear equation in two variable. Linear equation in two variable. Now here we have two variables, suppose x, y, a, b, z, x, anything. So let's take for example x plus y equals to 2. Now can you tell what is the degree of this polynomial or equation? Well, if your answer is 2, then it's wrong. The degree is 1. Yes, there are 1 and 1 degree to these two, and you might think that we need to add them. No, for addition, suppose the variables are in addition, then you are not going to add the powers as well. Okay, you are not going to add the powers. Now, if they were in multiplication, same question, but if they were in multiplication, then as you know that if the variables are in multiplication, then the powers will be in addition. Okay, so here is the degree 2. So this is also not linear equation in two variable. It should be linear. Sorry, this is not a linear equation in two variable. This is a linear equation in two variable. Okay, since linear equation suggests that it has power 1. Now let's talk about the general form that you guys need to know for linear equation in two variable. Okay, and this general form is very important for solving questions. General form. Let's write ax plus by plus c is equal to 0. Okay, this is the basic general form that you're going to need. And also there are some conditions. Let's say not conditions, but how the coefficients are actually. So A, B and C, these are coefficients. So all of them belong to, just one second, all of them belong to real numbers. This is belongs to sign. Okay, and also A is not equal to 0 and B is not equal to 0, because if these two terms are 0, then what's the point? Well, the chapter's name suggests that pair of linear equations in two variables. There won't be two variables, it will be one variable only. Okay, suppose A becomes 0, then by plus c is equal to 0, that's one variable. It will be still linear equation but not two variables. Now, there's one more point that you guys need to remember. I will write it in red pen because this is an important point. Star, there are infinitely many solutions for linear equation. Okay, just keep this point in mind because it is very important and they might ask this in MCQs. Okay, now let's talk about linear equation, two variable that we have been talking about for 5 minutes, I guess. Okay, now here I'm going to show you if they give you in a question two polynomials, okay, or two equations, x plus y is equal to 4 and 2x plus 3y is equal to 6. Then what is the general form and how are you going to solve it? Okay, now for example, let's take, you have x plus y equal to 4 and 2x plus 3y equal to 6. All the questions will be in this form only. They will give you two equations and you need to solve it. If they are said like this, then for the first equation, the general form will be a1x plus b1y plus c1 equal to 0. And for the second one, it will be a2x plus b2y plus c2 is equal to 0. Right. Now, we can say that a1, a2, b1, b2 and c1, c2 all belong to real numbers. Okay, and just in the first how I have explained that the coefficients cannot be 0, just like that the same process will be repeated, just more number of coefficients. a1 won't be equal to 0, a2 won't be equal to 0, and also just once again b1 not equal to 0, b2 not equal to 0. If c1 and c2 are equal to 0, that's fine, it doesn't matter. Okay, and suppose it's a1 square plus b1 square, also not equal to 0. Same for a2 square plus b2 square, not equal to 0. Okay, so that's the basic thing that you need to know, because you have to write this step, that a1 a2 b1 b2 in the question, okay, as a general form. Now let's talk about the types of lines that you guys are going to encounter in this chapter. Okay, now the first kind of line. Now you might be confused, what is line? Line is just a collection of points in a straight line. Okay, and this is going to be useful in solving graph questions, because they're going to ask you that what is the nature of this line, or how many solutions does this line have. Okay, in graph type questions. Now let's take for an example. Wait, let me first tell you intersecting lines. Intersecting lines. Now, as you know by the name also, that the lines are intersecting. Okay, so let's take this as y axis and this is the x axis, and where this x and y axis meet or intersect is 0. Okay, now suppose I have two lines here. One is like this and other is suppose like this. Okay, you will draw arrows like this so they are extending to infinity. Okay, we learned this in Euclid geometry also. Now, this point where these two lines intersect, not the x and y axis, but the lines which you get by solving the equations, where it intersects, it will have only one solution. One unique solution. Okay, one unique solution only. There won't be two, there won't be three, only one, and it will be unique. Okay, now let's talk about parallel lines. Quite easy, as you guys know by the name also, the lines are going to be parallel. Okay, so let's draw x and y axis. Sorry, this is y axis, this is x axis. Now, if lines are parallel like this, they are not perfectly parallel to each other, but yes, you get the point. Now, if these lines are parallel to each other, there's no intersection, right? If there's no intersection, then these lines will have no solution. They won't meet. They will extend infinitely, right? And they will never meet. So, no solution. No solution at all. Okay. Now, let's talk about coincident lines. Coincident lines. These are a bit confusing, but it's fine. Now, imagine you solve two equations and you get lines on the graph that are on each other, like one above the other, right? So let's draw this. So this is suppose one line you get, and to show the other line I will do it with a red pen. Here you go. So there are two lines now, right? One is this one. This you get by some xyz equation. Let's take for example x plus y is equal to 4, and this red line you get by 2x plus 3y equal to 0. Now these are just examples I'm telling you. Okay, they actually don't meet like that. These are for just explanation purposes. Now, as these lines are on each other like one above the other, they will have infinitely many solutions. You might ask why. Now, as you know, in the graph paper, there are small boxes like this. If you solve on graph paper, you will understand. So that you can draw infinitely many lines like this, and it can go till infinity or some fixed amount of time, fixed amount. Okay, so there it will meet at various points like this, infinitely many points. Due to these infinitely many points, the solution of this graph will have infinitely many solutions. Infinite solutions. Okay, so they are called coincident lines. Now, let's talk about some of the conditions that you're going to use while solving questions. Okay, when you're not doing this on the graph book, now suppose let's take the same example, x plus y equal to 4 and 2x plus 3y equal to 0. Now, suppose they have given you these two equations, 1 and 2. Now they ask you, without drawing the graph, tell us if these lines are intersecting, parallel, or coincident. How will you do it? Simple. Let's write the general form. A1x plus B1y plus C1 equal to 0. Second is A2x plus B2y plus C2 equal to 0. Right. Now, in order to tell them that they are intersecting, parallel or coincident, A1 upon A2. We're going to take A1 upon A2. Okay. Now, if we take A1 upon A2, that is going to be what is the coefficient of x? 1. And the coefficient of x in the second equation is 2. So 1 upon 2. Now B1 upon B2. That's 1 upon 3. Now for intersecting lines A1 upon E2 should not be equal to B1 upon B2. And then you can ignore C1 upon C2 because this has already satisfied the condition. Okay, now since this condition is satisfied, you can say the lines are intersecting. Okay, now let's talk about parallel lines. Now in the case of parallel lines, A1 upon A2 should be equal to B1 upon B2. But this doesn't stop there. You need to also write that B1 upon B2 should not be equal to C1 upon C2. If this condition is satisfied, only then the lines are parallel. Okay, only then they are parallel. And then you need to check the whole equation and then just take the coefficients and take them in division. Like A1 will be at the top and A2 will be at the bottom, denominator. If A1, A2 are equal to B1, B2, but B1, B2 should not be equal to C1, C2, then they are parallel. Now, last type of question that they might ask for coincident. Now, for coincident should be A1 upon A2 should be equal to B1 upon B2 and it should also be equal to C1 upon C2. Only then, only then the lines can be called coincident. Coincident. And what are coincident lines? Sorry, how many solutions does coincident lines have? Infinitely many. Okay, so also a question can be formed. Tell us that the XYZ equations are coincident, parallel or intersecting, and also tell how many solutions will they have. How many solutions will they have? So if you find coincident or parallel, you know that for parallel there are no solutions. For intersecting there's only one unique solution, and for coincident there are infinitely many solutions. So just write there are infinitely many solutions. Many solutions. That's it. Okay. So this is it for today guys. I hope you enjoyed my video. If you did, make sure to like and subscribe my channel.